To the binary classification. So as we discussed earlier, so binary classification means uh, the problem on which you are working, the variable what you are going to predict has only two distinct classes, either yes or no. For example, whether the patient is affected by the COVID or not. Can a bank issue a credit card to a particular customer or not? So such type of problems are called as the binary classification problems. And we discussed what are the different type of machine learning models or deep learning models are available to work with the binary classification problem. Also, we discussed yesterday. Today, we will discuss about the different type of error matrices. What are the different matrices uh, to evaluate the performance of a machine learning model or deep learning model for a binary classification problem. అంటే ఏదైనా ఒక మిషన్ లెర్నింగ్ మోడల్ అనేది బైనరీ క్లాసిఫికేషన్ ప్రాబ్లమ్ కోసం వర్కౌట్ చేస్తున్నప్పుడు హౌ ఇట్ విల్ పెర్ఫార్మింగ్, how we analyze the performance of the model in a binary classification problem. So what are the metrics are? So one of the metric is called as accuracy, another is called as a recall, another is called as precise, um, and F1 score. So these are the different type of metric analysis metrics are available. So let's take one small problem here. The problem, what the problem? Let's assume I have one machine learning model, and I want to build that machine learning model to predict whether a particular person has a diabetic problem or not, based on the glucose level, blood glucose level. Hope you understand. So I want to build one machine learning model to predict whether a particular person has a diabetic problem or not, based on the glucose level in his blood. So you can see, so let's assume, actually this is the data. Blood glucose is, if it is a blood glucose 66, so that means if it is a blood glucose 66, so is a diabetic negative. That means he is not affected with the diabetic disease. But if the blood glucose is 107, then he is affected. 1 means positive and 0 means negative. Diabetic positive and diabetic negative. So this is your original data. That means I have the one input feature. So based on this input feature, based on the glucose level, I'm trying to predict whether the person has a diabetic or not. So this is the data which I am using to train the machine learning model. So this data showing that if the blood glucose is 66, so no diabetic. The blood glucose level is 107, then he is affected with the diabetic. Okay. So now based on this data, let's assume I train the model. Oh, now the model is ready. So now while testing, if I give the blood glucose level as a 66, then that model is predicting as 0. That means, yes, he is not affected with the diabetic. So just to wait, look someone in the uh, lobby. Okay. So please clearly understand here. So now, when I'm giving the blood glucose level of a patient equal to 66, I'm entering that giving that input to a machine learning model, my model is predicting as 0. That means, so you don't have a diabetic problem. Actually, you don't have a diabetic problem. That means your model prediction and actual value both are same. When I'm entering the 107, then my model is predicting as a 1. That means he is a diabetic positive and actually he is a diabetic positive. That's good. When I'm entering the 112 blood glucose level, my model is predicting as diabetic positive. Actually, he is a diabetic positive. When I'm entering the 71, my model is predicting as a diabetic negative. He is also a negative. When I'm entering the 87, my model is predicting as a diabetic negative, but actually he is a positive. When I'm entering the 89, my model is predicting as a diabetic positive. He is also a diabetic positive. So this is the how my model is predicting, and these are what my what's called um, actual values. Okay. So now Okay, fine, leave it. Now, clearly see friends here. Based on this data, I want to prepare a confusion matrix. This is a very important. There may be a possibility that you will get one question in your final exam. That means the final certification examination from this confusion matrix. How we prepare the confusion matrix, now we will discuss. And from this confusion matrix, how we calculate the accuracy, that also we are going to discuss. Okay. So how we calculate the confusion matrix? So for this one, I require your active participation. So you have to respond so that it will be very interesting. So looks, can you please confirm all are online? Because I forget to share the screen, but no one asking about that one. Uh, so that's required me, right? If I'm saying something means I hope that you are listening, but I forget to share the screen, but you are not responding means it's not good at all. So I need your active participation here. So I hope my intention is I don't want you become an expert in AI. Just I'm trying to because I'm not giving that content also. It's a basic fundamental level of AI. So just I'm trying to give some idea about what mean by AI, some basic concepts. So if you participate actively, that will be very much interesting. Okay. So please be online, actively participate, and try to understand and get some knowledge from these sessions, and finally clear the certification, final certification examination. That will be more happy for me. Okay. Now, how we prepare the confusion matrix? So confusion matrix, it looks like uh, confusion matrix is looks like this. So this is like a confusion matrix for the binary classification problem. So so 0, 0. That means he is a diabetic negative. Actually, in the data, if it is a 1 means he is diabetic positive. And here N means what model is predicting. So this is the model prediction. MP means model prediction. A means actual values. So model prediction means, so model is predicting as a 0. And 1 means model is predicting as a diabetic positive, model is predicting as a diabetic negative. Now, how we prepare the confusion matrix, we will discuss. Now, from the table, anyone can please respond what value I have to enter here. So the value enter here is your actual value is negative and your model also predicting as a negative. Your actual value is 0, that means negative. Your model also predicting as 0, that is a negative. How many such type of samples are there in your data? So can you please respond, anyone? Dear students, I hope in our topic. So my question is from this data, from this data, how many samples were modeled diabetic negative and also actually he the diabetic negative? How many samples are there? That's how many are there? Anyone can please tell? How many samples are there? Such type of samples? Please respond. Please. So my question is, I data. So the data, three columns are there. First column is the glucose level of the patient. Second column is a actually he's a diabetic or not, that information. Third column is a how what model is predicting. So what I'm asking is uh, then how many samples are there where your model is predicting diabetic negative, actually he is a diabetic negative. That means your model given the value 0 and actually he is also a 0. That means diabetic negative. How many such type of samples are there? That thing I am asking. So anyone please? So one person is responded, I think. So Ajay Raj, thank you. And yes, thank you very much because we had the only one sample. Okay, thank you very much. So we had the only one sample, right? So now come to so this is the negative and prediction of negative. So the such type of samples are only one. So we will see once again our presentation. So here 0 and 0, one sample. No, not one sample. So why one sample you have? So actually 0, model 0, one sample. Here 0, your model also 0, two samples. So there are two samples, not one sample. So this is the two samples. Now tell me what is the value here. That means actually he is a diabetic negative, but your model is predicting as a diabetic positive. So how many such type of samples are there? Actually, he is a negative, diabetic negative, but model is showing as a diabetic positive. How many samples are there in this data? Anyone please see the negative, but your model is predicting as a diabetic positive. So 0, 1 case. So anything is there 0, 1. Is it 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1. So how many samples are there? No sample where uh, actually is a diabetic negative, but your model predicting as a diabetic positive. Such type of samples are not there, so that is 0. Okay, now come to here. Actually, diabetic positive 1, but your model is predicting as a diabetic negative 0. Okay, actually diabetic positive, but your model is saying that is a diabetic negative. How many samples are there? 1, 0. How many samples are there? 1, 0. These are 0, 0, 1, 1, 1, 1, 0, 0. Here we have the 1, 0, and here we have the 1, 1. So how many such type of samples are there? 1, 0 samples. So otherwise, I will do one thing. I will try to share this data file in the WhatsApp. So by seeing that one, if possible, please respond. So I need your active participation. Otherwise, there is no use only continuously I'm saying something. I'm expecting you need to learn something. Yeah. So just I shared the data file. By seeing the data file, please respond here. First, tell me. So how many number of samples where actually the person is a diabetic person, but model is predicting as a he is not diabetic person. So how many such type of samples are there? So one person is responded, I think so. No, it's not clear. Okay, definitely. I will explain once again. If you have any doubt, if you're not clear, I will explain. So if you ask like that, the question is, this is the data I shared with you. Already I shared this one with you in the WhatsApp group also. I am asking, so just I want to build one machine learning model. The purpose of that machine learning model is it is able to detect whether the person has a diabetic or not based on the glucose level in the blood, in his or her blood. Okay. So I have some samples. When the blood sugar is 66, so he's not a diabetic person. And there is one diabetic patient, his blood sugar is 107. Another diabetic person has a blood sugar level 112. Like that, some samples are, these are the actually he's a diabetic or not, it will show. Okay. Now, after training the machine learning model, when I'm giving the blood sugar value as a 66, my model tells that he is not a diabetic person. So 0 means not diabetic, 1 means he is a diabetic. So 0 means negative, not diabetic. 1 means positive, he is a diabetic. So when I give the 107, model is predicting as a diabetic positive. When I give him the 112, model is predicting as a diabetic positive, so on. Now my question is, I want to build a confusion matrix. I want to build a confusion matrix. So confusion matrix, how the confusion matrix looks like, you can see. So confusion matrix will be, it's the 2 cross 2 matrix. Okay. So the 2 cross 2 matrix. So here I keep the 0, that means diabetic negative. Here I keep the 1, that's the diabetic positive. So these are correspond to the actual labels, actual data. Whereas here 0 means diabetic 2, 1 means diabetic positive. So these are the model predictions. Okay. Now what this column represent? 0, 0. That means actually he's not a diabetic. Model also predicting he's not a diabetic. How many such types of samples are there? 0, 0 samples. 0, 0 samples. How many samples are there? You can see here. So 0, 0 samples. This is the first sample. And this fourth sample. These are the 0, 0 samples. So there are the 2 samples. Here I'm writing the 2 samples. And coming to here, actually is a diabetic negative, but your model is predicting as a diabetic positive. That means 0, 1 values where? Is there any 0, 1 here? It's a 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1. So there is no 0, 1 combination. So that's why it's a 0. Now I'm asking this cell. This cell represent actually is a diabetic positive 1. But your model is predicting as a 0, diabetic negative. How many such type of samples are there? So that is the question. So this data already shared with you in the WhatsApp group. So now please respond. How many such type of samples are there where patient is a diabetic patient, but model is predicting as a is not diabetic person? Yes, it is a 1. Yes, 1. Thank you. So it is a 1. So I will update this one as a 1. So this is the 1. Okay. Next thing. Now what about this one? So your actual and model also predicting as a diabetic person. So diabetic positive, model also predicting as a diabetic positive. How many such type of samples are there in your data? Anyone please? In your data, how many such type of samples are there? 3. I will check. Thank you, Pranati. So Pranati said that it is a 3. So Pujita L51, thank you. So we will cross check once again. So 3, that means 1, 1 samples. So 1, 1, that means diabetic positive, model also positive. Diabetic positive, model also positive, 2. So there are 3 samples. Very good. 3 samples. Okay. Now, so this is the 3 samples. Okay. So very good. So this is called as the confusion matrix. This is called as the confusion matrix. Okay, good. Now, what each cell will represent? So I will give some names here. So your model is predicting as a negative. Actually, he is a negative. That means your model is predicting as a negative. Actual value also negative. So this cell is called as a true negative. TN under. TN means true negative. So how many true negative samples are there? 2. So this cell is called as a true negative. Sorry. This cell is called as a true negative. Okay. Now, what about? So actually, your data is a diabetic positive and model also predicting as a positive. The model is predicting as a positive. So actually it is a positive. So this cell is called as the true positive. So how many true positive values are there? So, so your model is predicting the negative. So what we get F is false positive. So how many false positive samples? False positive because your model predicted the positive, but he is not a positive. See, he is not a positive, he is a negative. Model predicting as a positive. Is called as okay. Now anyone tell what it means? What this cell represent? Anyone please? What this cell represent is a bottom left corner. What that bottom left corner represent? Using chart box, anyone can tell? No. I will say. So my voice is not audible. So I will show this cell once again. So I'm asking about this one. This cell I'm asking. Are you able to see this one? This cell. So this cell represent. So actually model is predicting as a negative, but actually is a positive. So it is not true negative because model is negative, it is a negative, so it is a true negative. Coming to this corner, model is as a positive, it is a positive, so it is a true positive. Coming to this corner, model is predicting as a positive, but actually it's a negative, so it's a false positive. And what about this count, this corner? I am asking. Anyone please? What corner? Yes, it is Hakim. Thank you. So it is a negative. It's called as false negative. Someone responded in the group. Okay, fantastic. So please be online. So said that my voice is not clear. I will check my internet connection once again, please. Can you give me some time, please? Just 2 minutes only. Just 2 minutes, please. Be online. Necessary. Rama. So welcome back. So hope now this internet issues may be resolved again. So just observe my video a few more seconds. Let me know still if you have issues or not. Okay, and sorry because of this internet issue. So this part is called as the, so as Hakim said, so this is called as the false negative. So FN means false negative, false negative. Okay, how many false negative samples are there? So, so you will get this type of questions I will ask later. So false negative samples are only one false negative. Now, how we analyze the performance of a model? How we analyze the performance of a model? So how we analyze the performance of a model? So accuracy, in terms of the accuracy, we can analyze the performance of the model. So accuracy equal to true positive values divided by true negative values divided by sum of all true positive plus true negative plus false positive plus false negative. Formula. How many true positives are there? 3. And how many true negatives are there? 2. And what are the total samples? True negative plus true positive plus false negative. How many samples are there? Total 6. So divided by 6 into 100, it will give the percentage of accuracy. How much it was? So 5 by 6 into 100. So something around more than the, I think more than 80% of accuracy. 80% accuracy is there. So like that, we can analyze the performance of any machine learning model or a binary classification problem. Okay. So now I will give a small problem. So try to work on it and respond accordingly. So I will give one problem here. You can see. So because this type of questions will be coming in the your final certification examination. So I'm giving this problem again. Let assume, let assume you are working on a battery health monitoring application. You want to build one machine learning model. That machine learning model will take the state of charge of your battery, and based on the state of charge, so your model will able to predict whether that battery is a healthy battery or unhealthy battery. So let us assume few samples are there. I'm taking the few samples here. So S means samples, and actually it is healthy or not, and what your machine learning model is predicting. What your machine learning model is predicting. Let's assume your state of charge is 100, so it is a healthy. Okay, ne? So there is no fault. It is a healthy. So healthy, I will consider with a 0. 0 means healthy condition. 1 means not healthy condition. Okay. Okay. So now when the state of charge is 100, then it is a actually healthy battery. Okay. And that means there is no health issues, negative, no health issues. Okay. When it is a 90 state of charge, it is a healthy. That means no health issues. If it is a 80, it is a healthy, no health issues. If it is a 70, it is a healthy, no health issues. If it's 60, it is a healthy, no health issues. If it is a 50, it is unhealthy, some health issues. 40, unhealthy, some health issues. 30% state of charge, unhealthy. So 20% state of charge, unhealthy. Okay. Now, what your model is predicting? So let us assume I take one logistic regression model or descent tree model or ANN model, some model I'm considering. So that model able to predict whether the battery is healthy or not. Now I gave the battery state of charge as 100%. Then it is model predicting as a 0. That means uh, not a that means healthy. This is healthy. 0 means healthy. 1 means not healthy. Okay. So positive. So it's a positive pH positive healthy. That means healthy, negative, not healthy. Okay. So now, if it is a 90, so my model is predicting as a 0. If it is 80, my model is predicting as a 0. When it is 70, my model is predicting as a 1. That means unhealthy positive, not healthy. When I'm taking the 60, then it is predicting as a 1. When I'm giving the 50, my model is predicting as a 0. When I'm giving the 40, my model predicting as a 0. When I'm giving the 30, my model predicting as a 1. When I'm giving the 20, my model predicting as a 1. So based on this data, anyone can fill the what's called anyone can fill the confusion matrix. So negative, 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 and positive and positive. Okay, so positive, so negative I am representing with a 0. That means not unhealthy portion. Sorry. So I think it's a pH and NUH, not unhealthy. And it is a positive unhealthy. Whether it is unhealthy or not, I'm checking whether the battery is a unhealthy or not. If it is a 0, not unhealthy, that means healthy. If it is a 1, positive unhealthy, that means it is the unhealthy part. Okay, so this is the 1. So the N means it is a 1 or 0 and it is a 1. Now, can you please tell me now what value I have to incorporate in this column, in this cell? Anyone please respond. I want to build the confusion matrix. So how we build that one? Anyone, please? 3, Rohit. So I think someone responded. I want to cross it once. Anyone in lobby? I will check. So even after also you can ask any questions if you have. So write 3. I will cross check once again. So you said that it is 3. So that means 0, 0. See friends. So 0, 0 I am asking. 0, 0 means 1, 2, 3. Perfect. So it is the 3. Thank you. And what about this column? So this column is actually not unhealthy. That means healthy. And this is called model predicting as a positive unhealthy. That means model predicting as a unhealthy, but actually it is a healthy. So how many samples are there? Like means 0 and 1. 0, 1 samples, how many are there? Please respond. 0, 1 samples. 2. So someone writing 2, we will see 0, 1. So this is the 0, 1 sample, and this is also 0, 1 sample. So this is the 2 samples. Very good, very good, very good. So what about the sorry. Yeah, sorry, 0, 1. So 0, 1 is 2 only. Thank you. It's a 2 only. Now tell me what about this selection? So 1, 0 samples, 1, 0 samples, how many? 1, 0 samples. So positive, actually model is predicting as a negative, but it is a positive. It is a positive. Some health issues are there, positive health issues are there. But actually your model predicts no health issues. Okay, in the battery. So such type of samples, how many are there? So someone write near the 2, we will check once again. So what I'm asking, I'm checking for the actually 1, but the prediction is 0. Actually 1, but prediction is 0. This one and this one. So it is a 2. Very good. Okay. So now coming to this one. So what about next one? So your battery has a health issues. Your battery has a health issues. Your model is predicting as a health issues. So how many such type of samples are there? 1 samples. It is also again 2. It is also again 2. Very good. So like that, you need to prepare the confusion matrix. But in the examination, they will not ask you to prepare the confusion matrix, but they will ask the questions like that. How many true positive samples are there? How many true negative samples are there? How many false positive samples are there? How many false negative samples are there? So you have to respond to this one. Now, give the answer. How many true positive samples? How many true positive samples are there for your model performance? So just type a chart box like true positive TP -2 like that. So whatever you have the value that like that you have to respond. Yes. So true positives, it is a 2. Very good. So true positives are true. Now tell me how many true negative samples. True negative samples means actually negative, no health issues, and your model also predicting as no health issues. So how many such type of samples are there? Perfect. Perfect. 3. Very good. So this type of questions only you will get in the examination. So it's a 3. And what about the false positive? Yeah, very good. So she said false positive negative and false negative false positive 2. False positive means your model is predicting as a positive unhealthy, but it is a healthy. That means this section. So that is the false positive values are 2, and similarly false negative also 2. So if you want to, if you have any confusion, so you can write like this: negative, positive, negative, positive. So this cell is called as the true negative. This cell is called as the true positive. This cell is called as the false positive. This cell is called as the false negative. Like that you can remember. So true negative 3, true positive 2, false negative, sorry, true positive 2, false negative 2, and true positive 2, false positive 2. So like that you can prepare the confused matrix. And similarly, how we can calculate the accuracy? So accuracy of the model equal to true positive plus true negative. How many true positive plus true negative? True positive 2 and true negative 3 divided by all samples. How many samples are there? 2 plus 3, 5, 5 plus 2, 7 plus 2, 9, 9 into 100. So this is the accuracy of your model. So like that we can calculate observe the performance of any machine learning model that is used for the binary classification problem. Okay, but with this one it's not completed. So there is still we have to work on. So now coming to the next topic in the now I'm moving to the next topic. So now till now we discussed about the see, this is the what we are discussing. We discussed already true negative, false positive, false negative, true positive, and accuracy how we calculated true negative plus true positive divided by sum of all the samples that we are completed. Now another parameter is called the recall. Another parameter is called the recall. So recall is a matrix that measures the proportion of the positive cases that model identified correctly. In other words, compared to the number of patients who have been diabetic, how many patients are positive? So what recall means? Your model is predicting as a few samples as a positive, few patients as a positive. Out of few people, say let us look. So there is one machine learning based application. Oh, few people went to that application and provided the data. Okay, so once the people provide the data, your model is predicting as someone as a positive and someone as a negative, diabetic positive, diabetic negative. Now, what recall represent is among all positively represented by the machine learning model, how many are actually positive? అంటే ఏంటంటమ్మా ఒక మిషన్ లెర్నింగ్ మోడల్ దగ్గరికి వెళ్ళి మన డేటా ఫిల్ చేసాం. ఒక 100 కస్టమర్స్ ఉన్నారు, 100 పీపుల్స్ ఉన్నారు. 100 పీపుల్ కూడా ఆ అప్లికేషన్ యూజ్ చేసుకొని వాళ్ళు డయాబెటిక్ చెక్ చేసుకుందాం అనుకుంటున్నారు. సో అప్పుడు దే విల్ గివ్ సమ్ డేటా, సమ్ గ్లూకోజ్ లెవెల్ ఎంత ఉందని వాళ్ళు డేటా ఫీడ్ చేస్తే ఆ మిషన్ లెర్నింగ్ మోడల్ అనేది అతనికి డయాబెటిక్ ఉందా లేదని చెప్తుంది. ఓకే, ఆ విధంగా డయాబెటిక్ ఆ మిషన్ లెర్నింగ్ మోడల్ చెప్పేటప్పుడు మిషన్ లెర్నింగ్ మోడల్ ఎంతమందికి పాజిటివ్ అని చెప్పిందో అందులో యాక్చువల్గా ఎంతమంది పాజిటివ్ ఉంది, దట్స్ వాట్ ఇట్ ఈస్. యాక్చువల్లీ ఎంతమంది పాజిటివ్ ఉన్నారు. So that's what that recall represent. So how we calculate the recall value? So recall value can be calculated based on true positive values divided by true positive value plus false negative value. True positive divided by false negative value. So this is also called as the true positive rate. Recall also called as the true positive rate. You can see recall also called as a true positive rate. Okay. So there is another parameter called false positive rate. So only small change is instead of TP by TP plus FN, here we are writing the FP divided by FP plus TN. That's called false positive rate. Okay. Now based on this definition, now calculate what is the recall value of your machine learning model. What is the recall value for your machine learning model? So now tell me. So what is the recall value? So for this machine learning model, for this EV battery health monitoring, so what is the recall value for the model? Anyone can tell how we calculate the recall value? So recall value can be calculated as TP divided by TP plus false negative. So TP divided by TP plus false negative. So how many true positive values are there? Here we have the 2 divided by what are the true positive values? 2 plus false negative values are 2. So that means it is a 1/2 into 100. So recall value equal to 50%. Recall value is a 50%. Okay. So that means if there is 100 diabetic persons are there, only 50% of people are recognized correctly as a positive. Remaining 50% is recognized as not a diabetic problem. So that 50% recall is not a good in the healthcare. So you have to improve the machine learning model, but sorry, in the whatever it may be, 50% recall is not a good option. So you have to change the machine learning model or tune the machine learning model for the better performance. Okay, Nama? So hope you understand what you mean by the recall. So recall means among the available diabetic positive patients, how many diabetic positive patients are correctly identified? So that is the recall. Okay, and there is a one more parameter. There is one more matrix used that is called precision. So precision is a similar matrix to the recall, but slight difference. In the previous case, we considered TP divided by TP plus Fn, but here we consider the TP divided by TP plus FP, false positive. Okay, FP. This is called false positive. What it means represent is if a machine learning model tells is a diabetic positive, so among them, how many people are actually positive? That's what it is representing. So very slight difference between these two. So I will again try to explain the Telugu. So recall అంటే యాక్చువల్గా డయాబెటిక్ ప్రాబ్లం ఉన్న పేషెంట్స్లో ఎంతమంది పేషెంట్స్ని అది మిషన్ లెర్నింగ్ మోడల్ అనేది కరెక్ట్గా పాజిటివ్ అని రికగ్నైజ్ చేస్తుంది. దట్ రిప్రజెంట్ ద రీకాల్. ప్రెసిషన్ అంటే ఏంటంటే మిషన్ లెర్నింగ్ మోడల్ ఎంతమందిని డయాబెటిక్ ఉందని చెప్తుందో అందులో ఎంతమందికి యాక్చువల్గా డయాబెటిక్ ఉంది. రివర్స్ అనమాట. సో దట్ ఇస్ కాల్డ్ ద ప్రెసిషన్. సో రీకాల్ ఇస్ క్యాలిక్యులేటెడ్ యాజ్ TP divided by TP plus Fn, whereas the precision represented as the TP divided by TP plus FP. So you have to remember these formulas. Okay. So now in our case, so anyone can tell what is the precision value? Precision value. So that's equal to how many actually true positive and whereas how many positives that your machine learning model is predicting as a positive. So what the TP value now? 2. And what about your TP2? What is the FP2? So it is also 50%. So just I'm randomly chosen these samples. Okay, don't worry about this 50%. Just randomly I've chosen. So it is I'm showing as a precision value equal to 50%. So like that, there are the different metrics that are used to observe the precision and recall and accuracy. And there is one more parameter that is called F1 score. F1 score is nothing but which will combine the both recall and precision. It will combine the both recall and precision. Sorry, Niklesh. So Niklesh is in the lobby, I think. So it's better if you join before 1:30 because once I start the session, it is difficult to me, but no one is there. Okay. I am unable to see the lobby. Fine. Okay. And till now we discussed about the accuracy, discussed about the recall, and discussed about the precision. And the combination of the both recall and precision, that is called F1 score. So how we calculate the F1 score? So you can see here, F1 score is calculated as 2 into precision into recall divided by precision plus recall. Okay. So based on this formula for our EV battery health monitoring system, so EV battery health monitoring system. So what is the F1 square? Anyone can tell? So F1 score equal to 2 into what the precision 0.5 and what is the recall 0.5 divided by precision 0.5 plus 0.5. So what are the value? Its precision value equal to 0.5 now. So like that, we can calculate the precision value, accuracy value, recall value, and F1 score value. So these values should be more close to 1, then your model will be better. So you have to tune the various parameters of the machine learning model or change the machine learning model or change the data. So such that your model performance will be good, accuracy value, and all the values will be near to 1. So that's how we observe the performance of any machine learning model in a binary classification problem. Okay, so there's some chart box. Right. Thank you very much, Kalyan, Chandu, and all for giving the responses. So here I'm not discussing the much mathematics, anything. Just I'm trying to give some fundamental concepts only. How we analyze the machine learning model for the regression problem. How we analyze the performance for the machine learning model for a binary classification problem. That's it. Now, now we will move into the some next topic that is called one more called received operator characteristics. So there is another parameter that also used to analyze the performance of a machine learning model for a binary classification problem. So what is the received operator characteristics? So received operator characteristics, I said earlier, that is, uh, so you have to draw the a graph between the true positive rate. So with the false positive rate, we will discuss about the what is the true positive and false positive. You can see here, true positive rate is nothing but the recall that is called TP divided by TP plus Fn, and for false positive rate is nothing but the false positive divided by false positive plus. So cross sequence actually I am connecting the Ethernet only, and I have the internet also here, but Venkat says that some delay in the video. So cross-check once, Venkat, from your end also, internet issues. So I think I'm not using the Wi-Fi also. Previously, I'm using the Wi-Fi. Now I'm connecting the Ethernet. Achha, achha, okay, okay. Otherwise, I will remove here. We'll check once again. So can you confirm about my voice now? So I feel maybe some issues with respect to my earphones. Just I'm removing my earphones. So without my headset, I'm trying to deliver the lecture now. So just check for the next 5 minutes how my voice will be. Actually, that is the issue with the internet. Actually, I prefer a physical mode. So delay in the voice, not audio. Achha, achha, okay. Anyhow, I'm recording. Okay. So if my voice is not audible, please let me know. So till now we discussed about the performance of a model for a binary classification problem. Now we will try to work with the performance of a model for the categorical classification problem. I will share this PPT with you. At the same time, some materials also I will share, and also I will share the recorded videos. So, so what are the things in my hand? I am trying maximum resolving because previously I was connected to Wi-Fi. Maybe I thought there's the internet issue, so I connected the Ethernet. And I'm using the headphones also. We'll see. We'll see for the next 30 minutes until break. Later we'll check. I will restart my computer otherwise. Now, coming to so another parameter is called as the ROC, the ROC curve, that is received operator curve. And this curve is drawn between the true positive rate and false positive rate values. If the true positive rate value at the starting go up and it moving across the false positive rate, then we can say that your model is perfectly working fine. So if you have the more area under this ROC curve, if you have the more area under this ROC curve, then you can say that your model is perfectly fine. So otherwise, you have to change your hyperparameter further. And coming to the next topic, that is called the categorical classification problem. As I said earlier, categorical classification problem. So in the categorical classification problem, uh, so that means there are multiple classes. Like you are trying to classify the different types of the faults, like LG fault, LL fault, LLG fault, and triple LG fault. So they're the different type of faults. Or if you want to try to classify the mood of the person based on the tweet, like whether he's in a happy stage or he's sad or he's angry. So such type of problems are called as the categorical classification problem. Okay. Now, how we analyze the performance of any machine learning model on this categorical classification problem? It is slightly typical. It is slightly typical. So try to understand. So let's assume there is one problem I want to address with you. Let's assume I want to identify the type of the penguin species, type of the penguin based on its flipper length. Based on its flipper length, I'm trying to identify the what the type of the penguin. There is a different type of penguins, Adile and Gentoo and Chinstrap. So different penguins are there, which are represented 0, 1, and 2. So this classification is based on the length of the flipper length, based on the flipper length. If the flipper length is 167, it is a 0, ideally. And if your flipper length is 225, it is a 2, that means Chinstrap. If the flipper length is 197, then it is a Gentoo, 1. So there's a multiple classification problem. That means your machine learning model able to classify whether the penguin is a which type of penguin it is based on its flipper length. Okay. So this is the data. So let us assume uh, based on this data, I trained a machine learning model. So after training the machine learning model, what it is showing after training the machine learning model, so there's a different type of algorithms are there. One is called as the one versus rest algorithm, and it is called as the multinomial algorithm for the multi-classification model. In the one versus rest algorithm, we are using the sigmoid activation function, where the multinomial algorithm we are using the softmax activation function. Okay, so don't worry about these things because you may not get anything in the examination. But anyhow, I will try to simply tell what mean by the sigmoid activation function and what mean by the uh, softmax activation function. So sigmoid activation function means sigmoid activation function is represented as suppose if there is a one input, the input is x. And here I'm using the sigmoid activation function and my output is a f. Then f of x, output f of x equal to, for a sigmoid activation function, output f of x equal to 1 divided by 1 plus e power minus x. So this is the mathematical modeling of the sigmoid activation function. Okay. And where in case of the softmax activation, there is three classes are there. The three classes are there. Its output is x1, its output is x2, its output is x3. So then how the softmax activation function is? If you use the softmax activation function here, then your output will be equal to e power x1 divided by e power x1 plus e power x2 plus e power x3. So for this one. And for this one, so e power x2 divided by e power x1 plus e power x2 plus e power x3 for this one. And for x3, there is a e power x3 divided by e power x1 plus e power x2 plus e power x3. That's how we can calculate the output. So this is called as a softmax activation function, and this is called as a sigmoid activation function. So one versus rest algorithm, we are using the sigmoid activation function, whereas nominal algorithm, now multinomial algorithm, we are using the softmax activation function. It is for the categorical cross entropy or multiple classification problems. Now coming to our model performance. So actually when the flipper length is 165, so your actual species 0. When the flipper length is 205, your actual species 2. When the flipper length is 221, your actual species, sorry, when the flipper length is 183, your species type is 1. So I said that what mean by 0, what mean by 1, what mean by 2 previously. I think you can go ahead. 0 means Adelie and 1 means Gento and 2 means Chinstrip. There are the different types of penguins. So this is the data. But when we are giving the 165 to your machine learning model, that model is predicting as a 0 only. It is a 0, here also 0. It is a 0 and here also 0. When I am giving the 171, so it is predicting as a 0 and 0. When I am giving the 205, your model is predicting as a 1, but actually the species 2. Your model is predicting as a 1, but the species 2. Okay. So, and coming to when I'm giving the 195, actual species type 1 species, your model also predicting as the type 1. And 183 actually is 1, and your model also predicting as a 1. When it is a 221, actual species is the 2, model also predicting as a 2. It's the 214, it is a 2, and it is a 2. Now tell me, friends, by seeing this, I will share this data also in the WhatsApp group. So now help me to build the confusion matrix for this categorical cross entropy loss function. But in the confusion matrix slightly different when compared to the what's called binary classification. Now please tell me, please help me to build the confusion matrix for this case. So tell me, my confusion matrix will be like this. These are the predictions. And here these are the actual. So it's the 0, 1, and 2. Predicted as a 0 species, predicted as a type 1, predicted as a type 2. Is actually type 1 penguin, type 0 penguin, type 1 penguin, and type 2 penguin. Perfect. Perfect. Now, friends, already I shared the data with you. Now, what value I can keep here in the first column? That means actually it is a type 0 penguin. Your model also predicting as a type 0 penguin. How many samples are there? Such type of samples, how many are there? 2. So Pujita and Organt, someone responded. Pawan Kalyan, thank you. They said that 2, we will cross verify. Okay. So 0, 0. So 1 and 2. Yes, it is a 2. Thank you. So thank you for your response. So it is a 2. Like that, we will prepare the confusion matrix. And what about the 0, 1? 0, 1 means, so actually model is predicting as a type 1 penguin, but actually the type 0 penguin. So how such type of samples, 0, 1 samples are there? How many samples are there? 0, 1 samples. 0. Okay. 0, 1 samples said that the 0. We will cross verify. 0, 1 samples, right? 0 only. Very good. What about the 0, 2? 0, 2 means your model is predicting as a 0, but actually it is, sorry, your model is predicting as a type 1, type 2 sample, type 2 penguin, but actually it is a type 0 penguin. So how many the type of samples are there? 0, 2 samples. It is also 0. Okay, I will check once again. So it's a 0, 2. Yes, it is also 0. It is also 0. And what about the 1, 0? 1, 0. So you getting 0? Yes, okay. I'm not cross verifying. I'm writing directly 1, 0. Next 1, 1. 1, 1. That means predicting as a type 1 penguin. Actually, it is a type 1 penguin. 2. Okay, very good. Thank you. And what about the 1, 2? 1, 2. 0. Thank you very much. 0. Next, what about the 2, 0? 2, 0, 0. Okay. What about the 2, 1? What about the 2, 1? Okay, 1. And what about the 2, 2? 2, 2. Okay, 2. Right. So this is called as a confusion matrix. So this is called as a confusion matrix. Okay. Nice. Thank you. Now it's a confusion matrix for the categorical classification problem. But however, in order to calculate the metrics like accuracy, precision, recall, you can't use this matrix as it is. You can't use this matrix as it is. So you have to convert this 3 cross 3 matrix, or because we have the 3 classes, it is a 3 cross 3. If it is 4 classes, 4 cross 4. If it is 5 classes, 5 cross 5. But if you want to calculate the accuracy, recall, or precision, you require only 2 cross 2 matrix only. You have to convert into 2 cross 2 matrix. That means you have to build the 2 cross 2 matrix for every category. For every category, you have to choose the 2 cross 2. Okay, how that one we have to prepare? How we can prepare that one? I will tell. Carefully observe. Slightly complicated. So now you have to keep that matrix as it is. Now, with respect to the type 1 category, I want to build the confusion matrix, type 1 category. So confusion matrix, you have to convert into 2 cross 2 only. Done. So 2 cross 2. So 0 means negative, 1 means positive. So here type 1 means, so positive means, so that means type 1 criteria. So positive means that is the type 1 penguin. What mean by negative? Either 0 or 2. That is called as a negative. So negative means either 0 or 2. That is a negative. Like that you have to prepare. Now I am working at the type 1 penguin. Similarly, you have to prepare the I will repeat once again if you are unable to understand. Similarly, you have to prepare the confusion matrix for the type 0 penguin. So type 0 penguin means, so we are working with respect to 0, type 0 penguin. So type 0 penguin means, so positive is a 0, positive is a 0, and negative are remaining, these two are the remaining two are the negative. 1 and 2 penguins are negative. 1 type and 2 type penguins are negative. So that is the confusion matrix in 2 cross 2. And similarly, if you want to focus with the type 3, for type 3 penguin, so for this one, you have to respond, that will be more happy. So here, positive means what the value I have to write here in the bracket, or the value I have to write. Here the P, what the value I have to write? Type 3 confusion matrix. For type 3 confusion matrix, what I have to write here? See, when is it for the type 1 penguin, if you want to create a confusion matrix, positive 1, positive 1. And type 0, positive 0, positive 0. For type 3, what is the positive representation? 3, right? It's a P of 3 and it is a P of 3. And what about the negative? Negative represent what the negative? What negative? In the negative, in the bracket, what I can write? If you want to build the, yes, very good. L31, Sri Vigna, thank you. So it is a 0, 1, very good, 0 and 1. So if you respond, that will be very, even it is wrong, no issue, but I feel that someone is listening, that will be more happy for me. So 0, 1, right? So like that, if there is a 5 classes, you have to prepare the 2 cross 2, 5 2 cross 2 confusion matrices are required. If the 10 classes, 10 2 cross 2 confusion matrices are required. But to fill this confusion matrix, you have to prepare this confusion matrix initially. Okay, good. Now we are going to update. Now we are going to update all the values. Now see here, 0 and 0. How many samples are there? 0. See this cell, if you go to this cell will be 0, 0, 0, 2, 2, 0 or 2, 2. All the things will be comes under here. How many samples are there here? 0, 0 samples, how many? 2. 0, 0 samples are 2. And 0, 2 samples are 0, 2 samples are 0. And 2, 0 samples are 0. And 2, 2 samples are 2. So how many samples are there here? 2 plus 0 plus 0 plus 2. Total number of samples are 4. Total number of samples are 4. Hope you understand. Right? Now, anyone can tell what will be the value here in this cell, anyone? So I will do it for the first cell. You have to give the answer for the remaining. So for this cell, 0, 1. How many 0 ones are there? 0 means actually 0 and predicted 1. How many are there? So I will change the color. Yeah. 0, 1, this one, and 2, 1, this one. So how many are there here? So 0 plus 1, that's equal to 1 only. Okay. Now coming to here. Is a 1, 0. I will change the color again. 1, 0. How many 1 zeros are there? 0 and 1, 2, 1, 2, 0. Both are 0. So it's a 0. Now 1, 1. How many 1, 1 values are there? 1 and 1. That is a 2. So this is the confusion matrix for the type 1 penguin classification criteria for your machine learning model. Okay, hope you understand. Right? Now from here, with respect to the type 1 penguin, how many true negatives are there, false negatives are there, false positives are there, and true positives are there? Anyone can please respond. So you can type in the chat box as a TN4, FN, whatever it may be. So if you respond, that is very good. So at least tell me how many true negatives are there with respect to the type 1 penguin? How many true negative values? 4. Very good, very good, very good. Thank you. How many false negative values are there? False negative means it is predicting as a negative, but actually it is a positive. Predicting as a negative, but it is a positive. How many are there? Yes, yes, Akim, you are right. Anyone else? Yes, yes, very good, very good, very good. That's a 0. And what about the false positive? False positive means actually predicting as a positive, but actually it's a negative. How many such type of things are there? Predicting as a positive, but it is a negative. How many are there? Very good. Pranati, right, very good. Thank you. And how many true positives are there? Predicting as a positive, and these are predicting as a positive and a true also positive. Actual also positive. How many? So yeah, so right, right. It's the 2. Right. So this type of questions may come. I'm not saying same, but that type of so simple binary classification is very easy. But only if it's the categorical classification, slightly somewhat difficult. But mostly in examination, you will get the binary classification only. But anyhow, I'm explaining both. Thank you. Thank you very much for your response. So most of the people sir responded with a correct answer. Thank you. Now tell me, with respect to type 0, with respect to type 0, what is this first cell value? Anyone? What the first cell value? Very somewhat difficult, but try. So first cell I'm asking. Both are true. With respect to type 0. With respect to type 0, 5, 61, we will see. I don't know. Okay, we will see. So 1, 1. So 1, 1 means 1, 1 means this one, and 1, 2. 1, 2 means this one, and 2, 1. 2, 1 means this one, and 2, 2. 2, 2 means this one. How many we have? Actually 4, right? Yes, it is a 4. Oh, good. Something R, I don't know. So hit. So it is a so I think 2 plus 1, 3 plus 2, 5. It is a 5. Okay. And what about the Rohit? Looks it's right. Okay. So what about this cell? What about the cell? I will change the color. That means actually actual 1, but predicted as a 0. Actual 1 predicted as a 0. How many are there? This one, 1, 0, and 2, 0. 2, 0. This one. So it is a 0. Next 0, 1, 0, 2. How many are there? 0, 1, 0, 2. 0, 1, 0, 1, and 0, 2. This is also 0. 0. And what about the 0, 0? So 0, 0 values are 2. Very good. So I think Rohit, you're perfectly right. Now tell me type 3. Type 3. Anyone please? Type 3. Type 3. I will share here. Type 3. Negative, negative, how many? Negative, positive, positive, negative, like that. 4, 51, true positive, that means PP, 33. So true positives are no, don't write like that. Okay, I'm asking this cell, negative, negative. So 0, 0, 0, 1, 1, 0, 1, 1 criteria. So set that 4, we will cross verify that one. 0, 0, this one, and 0, 1, this one, and 1, 0, this one, and 1, 1, this one. So total 4, right? It is a 4. Now anyone can tell this cell, this one here, predicting as a positive, but actually it is a negative. They're called false positive. Okay. So how many such things are there? 0, 3, and 1, 3. 0, 3, and 1, 3. So not 0, 3. I think it is the 2. Sorry, 3. No, 2. Sorry, 2. 2. So tell me 0, 2, and 1, 2. 0, 2, this one, and 1, 2, this one. Again, it is a 0, I think. So it is a 0. So Rohit already gave the answer. We'll check. So again, 2, 0, 2, 1. 2, 0, and 2, 1. So it is a 1, right? And last one is 2, 2. That is equal to 2, right? So this is how we can prepare the matrix. Okay. Now by seeing this one, for the type 0, tell me how many true positives are there, how many true negatives are there, how many false positives, how many false negative. Sorry, for type 0, please respond in the chat box. So true negative 5. Yes. True negative 5. Okay. False positive 0. Yes, false positive 0. False negative, very good, 0. And true positive 2, very good. That's it. And coming to type 3, true positive, true negative, false positive, and false negative. How many? So now we are focusing on the type 2. Sorry, not type 3, type 2. Type 0, type 1, type 2, right? So type 2. So how many true positives are there? True positives are 0? No. So I'm asking for the type 2. Type 2. True positive. True positive. True positives are 2. True negatives are 4. And false positive. This is the false positive, 0. And this is the false negative, 1. So this is the answer. Is that right? Now our intention is to calculate the errors. Okay, accuracy. Sorry, accuracy. Now how we calculate the accuracy of the model? So to calculate the accuracy of the model, what we have to do is, so first note down your type 0, type 1, type 2. And here you can write true positive, true negative, and false positive, and false negative. Okay. Now tell me, we already have the data. For type 0, whatever the true positive, I think type 0, this one. So true positives are true, true negatives are 5, false 0, false negative 0. For type 1, true negatives are 4, false negatives are 0, false positives are 1, and true positives are 2. Okay. And what about the type 2? True positives are 2, true negatives are 4, false positives are 0, false negative is 1. Okay. Now take the sum. Take the sum. So what happened? 3, 6, 3, 2, 6 is a 13, and this is a 1, and this is a 1. I think you agree. So your true positive value is 6, true negative value is 13, true false positive value is 1, and false negative value is 1. Now, how we calculate the accuracy? So what is the formula for the accuracy? Now, based on the formula which I stated earlier, anyone give the value for the accuracy, anyone give the value for the recall, and anyone give the value for the precision, and also give the value for the F1 score. Again, we are using the same, but the criteria, that process will be different. So I'm expecting accuracy value. Anyone, please? I will share the screen with you. And in the WhatsApp group, by seeing this data, give the accuracy, precision, recall, all the things. And also, I will share formulas also. Already I shared, but I will share that formulas also once again. Yeah, this is the accuracy. Maybe it's available here now. Yes. Here only I can say accuracy, recall, and precision, and F1 score. So someone like 31 and Swati said that accuracy equal to 90%. Hope it is the right answer. Yes, it is a 90%. You can see the answer here. So our accuracy 90%. Right, Swati, you are right. And whatever 31 who are responded as 90%, that is right. Accuracy is 90%. And one person responded recall as 85.7. So recall is 85.786. That's also right. What about the precision? Anyone? So recall 86%. That's right. Precision 85.7. Right. It is 86. Right. So Venkat, that is also right. 86%. Very good. Overall F1 score. Overall F1 score. So anyone? F1 score. F1 score. Anyhow. So F1 score you will get around 86%. 0.86. F1 score is 0.86. Okay, very good. Especially I'm very thankful to all for your prompt response. That's required actually. Fine, thank you. So let's we move to the some other topic that is called clustering. So we have different problems: regression problem, classification problem. In classification, we have the what's called binary classification, categorical classification, and whereas in case of the now finally we move to the clustering problem. So yesterday we discussed, and slightly few more things we are going to discuss with respect to the clustering problem. So these all are the basic concepts. I'm not we are not discussing here implementation of all these things, but from fundamental concepts we are discussing. Okay, but definitely when you go for the if you build some skills related to the AI or machine learning in future, and if you want to go for any interview, so maybe you will get some questions related to the recall, precision, F1 score, accuracy, errors, all the things. Even though recently one project expo happened in our college, right? And that EV battery health monitoring team also presented their project. So they monitor the EV battery health using artificial neural network. And the examiner or experts who came to evaluate the projects, they ask the students about this one only, confusion matrix. Okay, but unfortunately, even though they are good, they did a very good work. But unfortunately, I forget to discuss about this confusion matrix with them. Okay, so hope that type of things will be come in your somewhere in your, if you participate in any competition or if you're going for any interview, you may get some this type of questions. Sorry. Now we will move to next topic that is called clustering. So clustering is a form of, as I said earlier, clustering is a form of unsupervised relational learning in which observations, there is no label data, only input data is available, only input features are available. And we group the input data, input features into the different clusters, different groups based on the similarities between the data points. Based on the similarity between the data points or based on the similarity between the features. So that is called as the clustering problem. So clustering problem is the example for the unsupervised learning, as we discussed earlier. So that the example for the unsupervised learning. For the clustering problem, we require unsupervised learning. For clustering problem, we require the unsupervised learning. So there is a small example I have answered here. Actually, there are the different flowers. You can see in the right top right corner, there are the different flowers are there. And I don't know the names of those flowers. Those flowers based on the similarities. What data I have the leaves. I have the leaf information, how many leaves are there, and also petals. Petals means these are called as petals. These are called as petals. How many petals are there? So based on that information, we are going to group the samples. So you can see this small how this unsupervised learning works. You can see this video. Finally, you can see I'm unable to keep a pause. At the end, these roll flowers comes together. See, these are on a group, these flowers are on a group, and these flowers are on a group. Lastly, they are identified like this. So these are grouping. There are different flower samples where X1, X2. So X1 represent the number of leaves and X2 represent the number of petals. And these are the data points. And these are dark blue dot is called as centroid. So based on the centroid, all these data samples will be grouped. How many groups are it will be grouped? How many clusters it will be divided? Finally, it will be divided into 3 clusters. And these 3 plots, 3 rose flowers looks like rose flowers in the one, and the remaining these 3 are another. And this the yellow color flowers are another. Like that, it will be clustered, like grouped. So this is called as the clustering grouping. In the grouping, we are using the centroid, and each flower represents one data point. Each flower on that image represents the data point, and that dark blue dot is called the centroid. Okay, this is called the clustering problem. So generally, we are using the claim is clustering and ANN. Such type of things can be used for the for this clustering problem for unsupervised learning. So coming to the metrics, so what are the different metrics are used to evaluate the performance of the model for a clustering problem? If we use some model, ANN model for to solve the clustering problem, how we evaluate? How we evaluate the metric? What are the metrics to evaluate the performance of the model in the clustering problem? So one metric is called the average distance to the cluster center. How close each point in the cluster is to the center of the cluster. That means we have the 3 dark blue dots, right? These are called as centroids. So flowers are called as the data points. These data points are how much far away from the centroid that will represent the one of the parameter average distance from the center. That should be as minimum as possible. Then your model performing better. సో ఇప్పుడు ఒక 3 రోజు ఒక గ్రూప్ కింద పెట్టేసి గ్రూప్ కింద డివైడ్ అయ్యాయి. ఇంకొక 3 యెల్లో కలర్ ఫ్లవర్స్ ఒక గ్రూప్ కింద డివైడ్ అయ్యాయి. ఇంకొక 3 ఫ్లవర్స్ ఒక గ్రూప్ కింద డివైడ్ అయ్యాయి. ప్రతి గ్రూప్ ఒక సెంట్రాయిడ్ ఉంటుంది. ఆ సెంట్రాయిడ్ నుండి ఆ ఫ్లవర్ డేటా పాయింట్స్ ఎంత డిస్టెన్స్ లో ఉన్నాయి క్యాలిక్యులేట్ చేయాలి. ఆ డిస్టెన్స్ అనేది తక్కువ ఉంటే దట్ ఇస్ ద బెటర్ మోడల్ అనమాట. అండ్ అనదర్ థింగ్, యావరేజ్ డిస్టెన్స్ టు అదర్ సెంటర్. దట్ మీన్స్ సో if you consider the rose flowers, so you calculate the distance of the rose flower from the other cluster centroids, So your rose flowers must be far away from the other centroids, other flower centroids. So that the average distance to the other center. అంటే నేనేం చెప్పాలనుకుంటున్నానంటమ్మా, I will show that video once again. So these dot blues are centroids. So the flowers are in this group. The center should be near to all these flowers. This center should be near to these three flowers. This center should be reaches to these three flowers. That is the first point. Second point is, and these rose flowers must be far away from the centroid corresponding to this yellow flowers. And the centroid corresponding to the rose flowers far away from the centroid corresponding to these six petals of flowers are there. Na? From there it will be far. So that is called the second point. Okay. That means average distance from the other center. And maximum distance to the cluster center, the furthest distance between the point to the cluster. So that also we have to identify. In a particular centroid, particular cluster, identify the centroid and also identify the point or a flower which is far away from that centroid. That's also analyzed. So that should be also low. Okay. So first parameter, second parameter should be as low as possible, and second parameter should be as large as possible. And there's the one more, this maybe comes in your examination, the new thing, Silhouette score. Actually, this is the content not available at the time of when I read the examination. These things are added in the November 1st. So maybe you are the first batch attempting the A900 examination as a fresh course. We will see how many are able to clear this examination. So don't be panic, but try to be interested. That's only important. Yes, నేను నేర్చుకుంటా, ఐ వాంట్ టు క్లియర్ దిస్ ఎగ్జామినేషన్ అని ఒక యాంగ్జైటీ ఇంట్రెస్ట్తో చదువుకుంటామా క్లియర్ అవుతారు. అంతేగాని పాస్ అవ్వాలా అనే భయంతో ఉండకండి. సో ప్లీజ్ బీ కూల్, లెర్న్ ద కాన్సెప్ట్, ట్రై టు learn and apply in the examination. So they will not ask any problems, any programs, any projects. Just they will ask the multiple choice questions or drag and drop type. Okay. So what is the Silhouette score? So Silhouette score is nothing but the B minus A divided by maximum of A by AB. So what is the B value? So B value is nothing but the distance from the average distance from the points in the one group to the points in the another group. Maybe these are the rose flowers, these are the some other yellow flowers. So what is the average distance between these two? That is called B. What is the A? Average distance within the cluster. Average distance within the cluster. So that is called as A. Now calculate the B minus A divided by max of A comma B. Then it is called as the Silhouette score. If this value is 1, means clusters are very well apart from each other. ఈ వాల్యూ మనకు 1 ఉంది అంటే your model is performing very well. Okay. So maybe ask following are the, so I will ask the question later. If it is a 0, means clusters are indifferent and we can say the distance between the clusters is not significant. -1 means clusters are assigned in the wrong way. So we are expecting that Silhouette score will be as close to 1 than the miscellaneous mode is better. Now in the examination you will got some questions like this. Like they will ask the questions like there is a 3 machine learning models are used to cluster the various flowers into the 3 different groups. And machine learning model 1 gives the Silhouette score value as 0.9, and machine learning 2 model give the Silhouette score value as a 0.5, and machine learning 3 give the Silhouette score value 0.95. Then which machine learning model performing well in this clustering problem? That's the question I'm asking. Please respond. See. I will show the screen again. Machine learning model score is 0.9, not 9, sorry, 0.9. Okay. And it is a 0.5 and it is a 0.95. Then which machine learning model performing well in case of the clustering problem? Based on the Silhouette score. Yes, model 3, because it has the more CL score value, which is more close to the 1. So that is the model is performing well. Model 3. Okay, Rohit, model 3, because it is a more score value, which is more close to 1, far apart. Okay, that's what required. Okay, the score value should be more close to 1, then the machine learning model will be performing well. Okay, if it is more close to 0 means it's not good. It's not clustered properly. Okay. So this is the thing about the clustering problem. Okay. Now we will move to the clustering problem completed, matrix completed, score completed. Now move to the deep learning. Okay. So before going to the deep learning, so we will take a break for the 10 minutes. So now it is the 3-5. I am requesting you all, please be in the online, but you can take a break for 10 minutes and please come back by 3:15. Thank you. Break up to 3:15.